Sorry, starting that off with my text message sound. It's not, that would have been awesome if that's how I started every PowerPoint. It makes me sound much more important than I am. Okay, so second to last PowerPoint. So that's good for you guys, EQ number 28. Second good thing for you guys is this is the easiest thing ever on the planet. So this should only take me maybe 15-20 minutes to explain, and then you have a worksheet to do right after this. So you can do the worksheet and the lecture in the same class period. It's so easy. You're going to be very relieved to see how molar mass works. We use it for much more in the fourth 9 weeks, but I'd like to just introduce it now so that it's not something we have to learn later. So molar mass or molecular mass, they're both the same thing. As it says here, hint, it has nothing to do with teeth, but you know, it's a fun picture to put on there. And your EQ is, how is molar mass calculated? It's so easy. You guys are gonna, this is a breath of fresh air after predicting the product. Okay, so here's the definition. And then some examples. So the molar mass or molecular mass is just the atomic mass from the periodic table, but we use grams instead of nothing, really, because we didn't really use anything when we learned how to calculate average atomic mass. So all we're doing now is taking the mass from the periodic table and attaching grams as the unit. That's it. Okay, that's all this is. So if you were to look up some on the periodic table, we know carbon is 12.01, so the molar mass of carbon, 12.01 grams. Molar mass of sulfur, 32.07 grams. Okay, just look at the number on the periodic table and attach grams to the end of it. Simple as that. This is not a challenge really in any way, I don't think. All right. So again, molar mass or molecular mass, it is the atomic mass expressed in grams. Hopefully I gave you enough time to write that. So really from here, there's some examples, and I think that's really it. Like you don't really need steps. I'm just trying to look forward a little bit. Yeah, that's about it. So I always do this. I stack them all up, and then I don't mean to. I should separate them so that I don't have to do this every time, but maybe on the last lecture I'll learn to do this the right way. So let's put this under here, and then do this, and then stack these, and now we're good. Okay, so it says first one, to give the molar mass for each. So we have potassium and we have tin. I gave one as the symbol and one as the name. Doesn't really matter either way. You should be able to come up with it, whether it's written out in words or in formula form. Okay, that's where you should be at this point. So potassium, all you got to do, look it up on the periodic table since it's just K. So if you look up at the periodic table, what is it telling you the atomic mass is for calcium? Hopefully you're looking, maybe you're looking at the one I gave you, but you should come up with, this is also to help you out, use the periodic table of elements in your notebook or the laminated one. All of those only go 2 past the decimal place. If you use the one on the wall, I know we all love that periodic table, but if you use that one gives way more decimal places than you ever need. So if you stick to the one that I gave you, or the one that you use on your tests and stuff, the laminated one, those are the numbers I always use. So if you always want your work to match mine exactly, use that one. You can use the one on the wall, but you're going to have to do a lot of rounding, and then your numbers may be a little off from mine. So just keep that in mind. So if you look up potassium on that periodic table, you should find that it says 39.10, and then you just attach grams to the end. That's it. Molar mass done. You found it. Good for you. Tin, if you look up tin, we know it's SN. You find it in group 4A. You look it up, it tells you that it is 118.71, and attach grams to the end. And you're done. Alright, so single elements, not bad at all. Okay, that's all you do. Nothing more than that. So obviously we don't always just work in single elements. We work with compounds mostly, which you've seen, right? That most of what we do are compounds. Sorry, I'm just trying to cross out the answers on the first one so we can calculate it together. When you're doing this for a compound, it's really not bad. Okay, you're just going to add up all of what you have instead of just, using a single element. So you might want to write this down. The molar mass of a compound is the sum of the molar masses of the elements in the formula. So that just means add them up. Okay, so I'll give you a second to write that. You can pause this now. Okay, I think it probably sounded a little bit like a robot before then, but if you paused it, great. If not, no big deal. So add up just all of the masses from the periodic table. So let's say I want you to calculate the mass of calcium chloride, CaCl2. So first thing to notice is you have 1 calcium, right, and 2 chlorines. So all you need to do is add up the mass of 1 calcium and 2 chlorines. So we've got 1 calcium, 2 chlorines. Look up the mass of calcium on the periodic table. It is 40.08, right? So 1 calcium with a mass of 40.08, that's going to give us 40.08, right? Not blowing your mind, I hope, anyway. And again, that's in grams, okay? We've got 2 chlorines, and if you look up chlorine on the periodic table, you see that it is 35.45. So all you need to do is make sure you multiply that by 2, because there's 2 of them. If you do 35.45 times 2, you get 70.90. Attach grams to it. All of these are in grams, okay? So now, to find the complete molar mass, just add them up. Okay, just like it says there. We're going to add these up. So I'll do it over here. We know 8 and 0 is 8, 9 and 0 is 9, 0 and 0 is 0, 4 and 7 is 11. So your complete final answer for the molar mass of calcium chloride is 110.98. That's it. That's as hard as this gets. All right, there's not much else to talk about in the way of molar mass. I like to just mention it. Just to throw it in there. So I'm going to have you pause this for a second so you guys can copy at least this part right here. This is just a little bit of a reminder when it comes to significant figures. It's not that difficult. So go ahead and write this sentence. I'm going to have you pause it, and then we'll do the example. You can look through the example, but go ahead and pause now. Okay, so there's only a few elements on the periodic table that I give you that don't have 2 past the decimal. So if that's the case, okay, if that's what comes up, then just remember to follow your significant figure rules. Keep the smallest amount of decimal places, right? Because we're adding and subtract. Well, we're adding. Remember, in adding and subtracting, you kept the smallest after the decimal. All right, so that's really all I'm reminding you of. So let's say I give you francium chloride. Well, francium chloride is FrCl, right? Because we know francium's a +1, chlorine's a -1. So you cross them over and you get FrCl. So all you're really doing is adding 1 francium to 1 chlorine. Not bad, right? If you look up francium, this is one of those exceptions. All it says is 223 grams. There's no decimal places. It's just because francium has to be estimated to a whole number. It means we probably don't know much more than that. Chlorine, though, is 35.45. We have the 2 after the decimal place for that one. So add them up just like you normally would. You get 258.45. Okay? Like it says, 223, if you go back to these two numbers you added up, this one has none past the decimal, this one has 2, so you have to keep none past the decimal. So 223 has no numbers after the decimal, so your answer can't have any. So your final answer, just follow normal rounding rules. The 4 is not going to round the 8 up, so your final answer would be just 258 grams. Sorry if you couldn't see that whole thing during that explanation. Alright, so again, 223 plus 35.45, you can't keep the 0.45 because you don't know what these decimal places are. So you can only keep your whole number, follow rounding rules, you get 258. Most of the time you're going to be able to keep 2 after the decimal. But in the event that you have an element that doesn't give you any past the decimal or only gives you 1 past the decimal, this is just a reminder of what to do. Alright. I have one more example we can work through. Actually, yeah, let's do 2 more. Just to make sure, and I'm going to give you these in word form because I can tell you that's probably how most of these are going to happen for you. That's just the way chemistry is. You got to be able to convert to formula form. So that's the only way molar mass is going to be difficult, is if you still don't know how to do this. If you don't know how to convert to word form, then this is not going to be easy, but I imagine you've struggled a lot through this whole 9 weeks. So I can just tell you it's not going to get any easier in the 4th 9 weeks. We're continuing on with writing reactions in molar mass. We're just adding more math into it. All right, so if you haven't learned how to do this yet, I'm telling you it's not going away. So you're either going to keep struggling or you better figure out a way to educate yourself before we continue on. Alright, so I want the molar mass for potassium oxide. So first things first, convert it to formula form. So potassium oxide, is this ionic or covalent? Hopefully you are correct when you say ionic. So what do we need to look up for each one of these? Good, we need to look up this, well, the symbols obviously, but the charges more importantly, right? So we know potassium is K. And then oxide is just oxygen, right? Because it ends in IDE, it's just that one element. Oxide is oxygen. So potassium's charge is a +1. Oxygen's charge, -2. What do we do with those charges next? Let's hope you are saying we cross them over, because that's exactly what we do, right? Ignore the charges, cross the numbers, K, 2, O. Okay, so first step done. Now, all you need to do is add up the masses of these. Alright, so this is just the way I like to do it. You got 2 potassium times the mass of potassium. Sorry, I'm going to zoom in a little. So 2 potassium times the mass of potassium. What's the mass of potassium? It is 39.10 grams. You guys are going to be proud of yourselves at the end of this on how many of these, the molar masses from the PR table, that you have memorized, because you're going to use them so often, you're going to know a lot of them by heart. I do. You'll get there too, where you know a lot of them because you use them so often. So next one, how many oxygens do we have to account for? Just 1, right? So it's 1 oxygen times, and what's the mass of oxygen? It is 16.00 grams. Good. So if we are going to do some calculating, so you just need to do 2 times 39.10. So if we do that, sorry, I don't already have this one worked out. 39.10 times 2 is 78.2 16.20 grams. Should have known that. That wasn't that difficult. And then 1 times 16.00 is obviously just 16.00. Next thing you want to do is add those up. Right, if we add 78.20 plus 16.00, we get 94.20 grams of K2O, molar mass found. All right, and obviously it's not going to take you this long once you actually start doing the practice on these. It's just because I'm, talking through step by step. You don't have to do that. That'd be pretty funny if you did that every time you did a problem. You talked yourself through it. But you should be able to get through these pretty quickly once you start the worksheet. Last one, aluminum hydroxide. So we need to write out the name or the formula form first. Is this ionic or covalent? Definitely ionic. Aluminum we treat as a metal. So we know that's Al. Hydroxide, not on the periodic table, right? It's a polyatomic ion, which all of you can look up. If you look up hydroxide, you know it is OH with a -1. What charge will aluminum form? Good, hopefully you are saying 3, +3. So cross your numbers, or cross your charges since it's ionic. Ignore the symbol. Cross the charge. You get Al, and I know everything in you just wants to do that, right? AlOH3, but remember, OH is a polyatomic ion. They travel together, so you gotta put parentheses around it. All right, AlOH3, that 3 must apply to both the oxygen and the hydrogen. All right, so now let's go ahead and do our math. So we've got 1 aluminum. How many oxygen do we have to account for? Remember, this applies to everything inside. So we have 3 oxygen, and how many hydrogen? Not a trick question. Also 3 hydrogen. Okay, so you have that. Next, you need to look up their masses. Aluminum, if you look it up, is 26.98 grams. Oxygen, we just did in the last one, is 16.00. And hydrogen, 1.01. All right, so your math is set up. You've got 26.98, right? Because it's just 26.98 times 1. 16 times 3, you get 48.00. Remember, you want to keep those zeros because we know they're zeros. We wrote them because we know them, so you don't want to change your significant figures. And then 3 times 1.01 is just 3.03. So all of these are in grams. Add them all up to get your answer. So 8, 0, and 3 is 11. Carry your 1. 1, 9, 0, and 0 is 10. Carry your 1. You got 14, 15, 16, 17, 18. So put your 8, carry your 1, and then 6, 7. Obviously, you'll have a calculator. You don't have to do this by hand, but it's easier for me to do it on the paper like that. So your final answer is 78.01 grams, and then always include all of the labels. So this is 78.01 grams of what? Of AlOH3. Right, just like in math, you have to label everything. You have to include units on everything, or else you might lose some points later on. Okay, so 78.01 grams of AlOH3. That's your answer. That's all I got for you. Told you, about 20 minutes, right? We're at 19 minutes and 19 seconds. Yeah, that's it. That's the last slide that I have for you. Go ahead and you can get your worksheet then from Mr. Perkins and work on this for the rest of the class period. Hopefully it's a little bit of a break. Miss you guys very much, and have a fantastic day.